Sorry, unmuting the microphone is a good idea, isn't it? Still loading the stream. It takes some time on the app. Should be good to go in a sec. Explain the code in a bit of what we are working on. We comment this out. Should actually work. That's what the game looks like. Give me a sec. Just post this link quickly. We normally use LinkedIn as well. Let's try an actual event on LinkedIn. Try this. It's actually doing something, making mistakes and things. I wish there was be like an automated thing to say continue. But yeah, hopefully it will solve this problem for us that we're currently having. I'll explain it in a sec. Just copying, just still testing things. What's called LinkedIn has a start drafting a draft with AI thing for a post. Draft with AI beta. Can actually show you. That's what LinkedIn must have integrated a ChatGPT or something into it, or the Bing, must be Bing. So if I write this, create a draft, show you why is this marked up? Oh, minimum 9. What? I don't get it. What's the problem? No. They need 30 words. Why? ChatGPT can do it for you. What's don't even need the GPT-4, do we? Can just expand. create a link in post. So why is the dropped with AI bit? I don't know what the details are. Yeah, how about make it shorter, about 2 or 3 sentences. So it's still putting those icons. What? Why is it? So what is this GPT-4 as well? 21 words. No, I just want to see how it works. It needs minimum of 30 words. Why? I don't get it. Is this create draft? What is this? Yeah, I have to get rid of all this. Game development integrates GPT-4, real-time ECG, wave scoring. Is some rubbish. Obviously, it's a game. Hopefully, it's understood. Just something red. Yeah. It's always LinkedIn is always causing trouble. Yeah, I lost the link. Yeah, the link. So this is the game. Let's test this working on it for the last couple of days, ChatGPT was able to actually do some useful stuff for us, which is great. Let's see if the text to speech is actually going into
Waveform concatenation. Generate segment underscore count waveforms and concatenate them horizontally. Let's implement these changes. Waveform segment generator. Instead of producing a single waveform segment in your while loop, you should produce multiple segments and concatenate them together.
So trying to, for the script to be able to display multiple waveforms on the screen instead of just the one. By the way, this is abnormal ECG, so we can get some points. Once you get extra 50 points, it will start running faster. Oop, that was normal. And if you're getting things wrong, it will start going slower again. So this is abnormal ECG. Oh, this is normal. This looks normal. This looks normal. This is abnormal because it's missing the P wave. This is abnormal as well. This is abnormal. Abnormal. Normal. Yeah, and it's getting much faster, so it's much becomes much more difficult. That was normal. That's normal. This is, I don't know, it's too fast. Right, so we have this problem. So we want to, well, not a problem, we want to improve it. So I want to display. So yesterday, for example, we had a problem where if you just randomly click on things, because you were getting 10 points for correct response and only deduction of 5 points for incorrect response, just by you clicking randomly on anything would keep the score going up. So we fixed that by essentially giving the same, deducting the same amount of points for incorrect response. So if essentially, so the idea is to find abnormal ECG patterns, avoid clicking on normal ECG. So it suggests that you should be clicking on the screen. Can be clicking anywhere. Yeah, this score keeps going up. So essentially what happens now is if you keep just randomly clicking, the score will remain about the same. Because you have at this stage, you have 50% normal and 50% abnormal of different types. Actually, when we hit P, in theory, we should be getting instructions. What should be H for help or something, I for instructions. Ideally, with like a button on screen. So hopefully we'll add that today. But we have all these other abnormal waveforms that are being, that are running on the screen for you to detect. So there might be, and yes, there should be like an instruction manual coming up as well that will show what type of waveforms and explain, how to play the game and things like that. So you have the regular waveform, it will come up 50% of the time. Then, and the rest is divided by, you have 7 abnormal types of ECG. One, you have different size of the QRS complex, 3 different versions of that. And then you will have, this is wrong. This is wrong. We will have a version with no Q wave. Let's quickly. So this code is calling another function. No, it doesn't. Okay, so there's a few things we need to correct. We have also options for no S wave, no T wave. Can bring some ECG waveform example. That's what Google Images will show. Right, P, QRS, T. Later we'll also add the, so those are abnormal ECGs. No, they're not abnormal. That's explaining what's happening in the heart for every stage in the waveform. But essentially, currently we're just varying the amplitudes of this. So the three QRS variation 1 to 3 will be different amplitude of the QRS complex, different shapes as well. And then we have no P wave, no Q wave, no S wave, and no T wave options. But we have to improve quite a few things. We had this problem in the code. Let's actually have another problem. A problem. We have a problem in this code that some of the waveform types, abnormal waveform types, are not included in the game. Some of the abnormal gain types are not included in the game. We have another problem. Another problem is that when we generate multiple, so currently we don't see multiple waveforms. Another problem is that we don't see multiple waveforms on the screen at once. To break this one, a third problem is when we generate multiple waveforms, we don't want the same waveform. We want to use the same. Okay, let's break this down. Right. So now problem is that when we generate multiple waveforms, yeah, we don't want the same waveform. Yeah, maybe like this. Let's pop this in. We started with one problem, now we have three.
Thank you for detailing the issues with the code. I understand the concerns and will address them sequentially. Inclusion of all abnormal waveform types will make sure that each abnormal waveform type has an equal chance of being selected. Display multiple waveforms at once will modify the logic to concatenate multiple waveforms horizontally so that they appear on the screen simultaneously. Avoid generating the same waveform consecutively. We'll implement a mechanism to ensure that the same waveform type isn't generated consecutively.
That's working on the code. What's that lambda is all about? Generate a concatenated waveform consisting of multiple segments. Each segment is selected randomly, but won't be the same as the previous segment. That's great. Generate yes. Generate the segment, yes. So it will look like this. Good. I don't know why it keeps reversing my stuff.
The function generate multiple waveforms now generates concatenated waveforms made up of multiple segments. As shown in the plot above, the function produces waveforms with different segments placed side by side. I'll now integrate this into the game logic to address the issues you mentioned. Ensure all abnormal waveform types are included. Display multiple waveforms on the screen simultaneously. Avoid generating the same waveform consecutively. Let's implement these changes. Working. Show work. Stop generating. Sorry for the oversight.
We made some mistake. Well, it's trying to. So the problem is, by default, Code Interpreter will try executing everything on the OpenAI server. And I'm doing everything locally, so that's obviously not needed.
Sorry for the oversight. As mentioned earlier, Pygame is not available in this environment. However, I've integrated the logic for generating and displaying multi-segment waveforms into the game loop. To implement the changes, copy the generate multiple waveforms function and the updated game logic provided above. Paste them into your local environment where Pygame is installed. Run the game. With these modifications, the game should now include all abnormal waveform types, display multiple waveforms on the screen simultaneously, and avoid generating the same waveform consecutively.
Right. So it's ending with Pygame quit. But is it the whole code? No. I'm having trouble to integrate things. I understand what it's doing, maybe. No, we haven't checked what it's doing, but for us to actually test it, we need the whole code. We're already over 100 lines of code. We're around 200 lines of code. Before we had 2 Python files calling one another, one calling the other, but that's hard to work with. So we've put everything back into one file. Can it generate a whole file without any placeholders or missing bits? And I also don't want it to execute things on the server. I need the code because I'm running everything locally. Yeah, this is an interesting bit in Code Interpreter. So it's using Python. It's so now supposedly generating the whole script. It has this bit, ECG Wave from generation functions. Is it the placeholder? No, it actually has all the functions. Right, we have variation 1, 2, 3. Yeah, we have no P wave. Now, yeah, I don't know why this is not just 300, 600 divided by 2. That minus there is good because it actually indicates that the whole waveform should be inverted. So that's good. it's obviously changed this bit waveform. What's lambda doing? Right, so we have a default. So when we generate multiple waveforms, we have default of 3. This should also make sure the waveforms are not repeated. So the same waveform is not repeated twice. Don't quite get this bit. Right, so this indicates which one's normal, which one is abnormal. So we have only a normal ECG and 1, 2, 3, 4, 5, 6, 7 examples of abnormal ECG, which is correct, or currently correct. Let's just run it. We should have the same game logic. Yeah, we have this bit does the scoring. So plus 10, minus 10. Right. Apologies for the premature termination of the script. Let me complete. Here's the continuation. Okay. But the continuation. Okay, let's save. Yeah, yesterday we had a bunch of examples that we can get rid of, because this code is still, the last code is still better. Keep copy of this and pop this new code into Cardio Quest Python script. Then we have a continuation of it. Pygame draw lines. Pygame quit. So it will be from this bit onward. And the main thing we are looking for is that we should have multiple waveforms on the screen at once. So we can run, see what we get. No, we can still have the one. One sec. This must be wrong. It's obviously abnormal thing. I don't know what it does, but it's not correct. Where's the bit? The segment count is 3. Just pop this in. Don't even know what the problem is now. We definitely don't see multiple waveforms on the screen. But how do I generate multiple waveforms? So that's a function. Default is 3, but is the default actually being used? What? It's being called 3 times. New wave, new type. Obviously need annotations. The ratios are still the same. I don't see the ratios. Where did that go? Use different ratios. Be on the screen. And just get rid of like about 50 lines of code as well. Okay. Yes, we have the libraries. So we have the required libraries. One question, why generate multiple waveforms being called twice? How many waveforms are currently displayed? And when testing, I had the waveform flatlining for a while. Where is that coming from? So the calling the function
The initial call to generate multiple waveforms at the start of the game logic is to fill the screen with waveforms for the first time. The subsequent call inside the loop is for when the current waveforms have scrolled off the screen and new ones need to be generated. Number of waveforms displayed. The generate multiple waveforms function has a default parameter segment count equals 3, which means it will generate 3 segments, or 3 waveforms, by default each time it's called. If you want more or fewer waveforms at a time, you can change that number. Flatlining issue. The flatlining, a straight line, occurs when the generated waveforms don't fill up the screen width completely. This can happen if the combined width of the waveforms, from generate multiple waveforms, is less than the screen width. The flatline is essentially the background showing through. To fix this, we can ensure that the generated waveforms always fill the screen by appending more until the width is covered. Let's address the flatlining issue. To fix the flatlining issue, we need to ensure that the screen is always filled with waveforms. This can be achieved by looping until the waveform's length matches the screen width. Here's how we can modify the part of the code that generates waveforms inside the main loop.
I don't think that's what the problem is. It's that width bit. New wave. So essentially when I'm calling generate multiple waveforms, let's ignore the last comment and address another problem. I do not see 3 waveforms on the screen. I only see 1. Let's start from something more basic.
See the confusion. The generate multiple waveforms function does indeed generate multiple waveforms, 3 segments by default, but since each waveform segment is based on the same time interval, t values, they look like a continuous singular waveform when appended together. Each segment could be a different type of waveform, normal, abnormal, etc., but they are all plotted over the same time interval. To visualize multiple distinct waveforms on the screen,
What?
they look like a continuous singular waveform when appended together. Each segment could be a different type of waveform, normal, abnormal, etc., but they are all plotted over the same time interval. To visualize multiple distinct waveforms on the screen, we would need to space them apart or perhaps introduce some kind of separator between them. One way to achieve this is by introducing a flat line between the waveform segments. Here's a possible approach. Modify the generate_multiple_waveforms function to add a small flatline segment between each waveform segment. Adjust the generate_multiple_waveforms function to generate fewer waveform segments initially so that they fit on the screen and can be visually distinguished. Let's implement these changes. Here's an adjusted version of the generate_multiple_.
I don't get, that's not what it does. I mean, if 3 waveforms was selected, they're not actually being shown, so the time is not adjusted. Yeah, in this bit, what's that all about? And this is abnormal. Yeah, this is doing something super weird. It's all abnormal. Yeah, it's doing some funky business. Ignore the last comment. Let's correct another problem. Is the time variable for the x-axis was modified to show 3 waveforms at once? Or was the width of each waveform adjusted so that 3 are visible? Yeah, I really don't know what's up with that.
Understand the confusion. The t_values variable determines the x-axis or the time interval over which each waveform segment is generated. If we want to fit 3 distinct waveforms on the screen simultaneously, we have 2 primary approaches. Adjust the time interval, t_values. This would involve compressing the x-axis for each waveform segment so that 3 segments fit within the screen width. This might, however, distort the visual appearance of the waveform.
Or adjust the screen width. I would probably do a bit of both because the screen is would be too narrow at the moment.
Adjust the screen width. This involves widening the screen so that 3 segments of the original waveform can fit. This would maintain the visual integrity of the waveform but would require a larger display area. Given these options, which one would you prefer? Or do you have another approach in mind?
Yeah, we do have another approach in mind. Can you do a bit of both? So first, reduce the t values. So compress it. Probably half it. And then also have an option to adjust the screen width so that more waveforms can be displayed. This is just wrong.
Adjust the time interval, t_values will have the length of t_values, effectively compressing the waveform in the x direction. This will make each waveform segment half as wide. Adjust the screen width. We can add an option to set the screen width to a desired value to display more waveforms. Here's the modified code. Python. Copy code. This code allows for a compressed waveform because of the half t_values and provides the flexibility to adjust the screen width using the screen_width_multiplier variable. Setting it to 3 will make the screen 3 times as wide, which should allow 3 segments of the compressed waveform to fit.
Wait.
This code allows for a compressed waveform because of the have t_values and provides the flexibility to adjust the screen width using the screen_width_ multiplier variable. Setting it to 3 will make the screen 3 times as wide, which should allow 3 segments of the compressed waveform to fit. Adjusting this multiplier will show more or fewer waveforms on the screen.
Right, let's do the first bit first. The t values. Right, so it's just halving that. Let's see what we get. It looks like that doesn't look right. Oh, come on. It's not right, not right. T-value has been called 4 times. Allow the same custom. So this will be at the end. No, wait. Are you sure we had this bit already? Right. Game logic screen width. With multiplier. Wait, so this is not what I was thinking, but we can try it quickly. Font. What's the problem with the font? Yeah, let's show what's up with the font, but it should be simply this bit. Right, so the screen. Okay. Yeah, I have this crazy long screen. Then I'm not sure what's happening in terms of yeah, maybe we'll just make it width multiplied by 2. Right, this is better. Does it fit? Yeah, it doesn't quite fit like a regular screen. I have this like ultra wide screen, but then the other problem is this bit. Just start it again. So we have normal, some sort of semi-normal ECG first. Maybe we can set 2 multipliers, one for vertical and other for horizontal. That's a good point, but I'm currently not so much worried about the horizontal thing, except it being centered horizontally. I'm only, I want it to be centered in the middle, so this doesn't go all the way up there. But the reason I made the screen wider is that I can see multiple waveforms. Before, I could only see one. So I was, so essentially in the game, I want to be able to have multiple waveforms coming through, and you meant to click on the screen selecting where the ECG is not normal. So it does it now. So I have 3 waveforms being displayed, which is fine. But now I'm having this other problem. So so ChatGPT fixed that and stuffed up something else. So we had this, I didn't mention that problem before. It should be in the bottom of the previous code. That we don't see so we now do see multiple waveforms. I just copied this quickly. Problem is because some normal waveforms type are not included. So I think now they are included. So we have 7 types. I don't know what it does probability wise. So now all the abnormal waveforms, there's 7 of them, are included in the game. How do you choose the probability for each? So that's one thing.
Yes, in the current setup, all the 7 abnormal waveforms are included in the game. The probability for each of the abnormal waveforms is determined by the following logic in the generate_multiple_waveforms function.
Oh yeah, definitely pushing it to GitHub. I'll probably, the Python script can go up today. I can do it right now if that helps. It actually should be on my website already, but it will be like unlisted. So if you're watching this, you should know what it's called, and you can just find it on the website. But yeah, I'm more than happy to push it onto GitHub. Can probably do it straight away, but I first wanna just address these couple of things. And yes, happy for the Python code to go on GitHub, but then I'm also be turning the whole thing into a web application. So hopefully just turning it into JavaScript if there's nothing complicated that has to be done on the server. And if there is something on the server, then I'll be using Flask or whatever. Just trying to get
In the
this
current setup,
first.
all the 7 abnormal waveforms are included in the game. The probability for each of the abnormal waveforms is determined by the following logic in the generate_multiple_waveforms function.
Wait, so where's that function? 0.5. Got so that's the crazy thing about it. It got rid of this function, which I definitely had before. And now it's saying that it's there. It's like, it's lost the context a bit. So all the abnormal waveforms are there. There are 7 of them. How to choose the probability. So I'm pretty sure if I pop this back, hopefully that last comment, it should say get it.
The provided code, the probability for each waveform is determined by the method used to generate them in the generate_multiple_waveforms function.
Yeah, I was wondering what that lambda thing is doing. What is lambda? What's lambda? Is it a thing or there's a section? Random choice. Oh, where the weights? No, it's suggesting me to add it. So the idea was that you will have 50% normal and 50% abnormal. Within the 50% abnormal, you choose one of the 7 abnormal waveforms. Anyway, the code I had before was better. Yeah, it stops it up for me. First, I didn't have this wicked thing. Obviously, we have a copy. Oh, come on. Let's pop this back in. Okay, let's see what it says first.
This logic ensures that consecutive waveforms aren't the same, but it gives all waveforms, both normal and abnormal, an equal chance of being selected, which is, or 12.5% for each waveform given that there are 8 different waveforms, 1 normal and 7 abnormal. If you'd like to adjust the probabilities, you can modify the method of selection. For example, if you want the normal waveform to appear with a 40% probability, and the rest to be divided among the abnormal waveforms, you'd need to use a different logic for generating the random index. One way to achieve that is by setting weights for each waveform, and then using NumPy's choice function to pick an index based on those weights.
Wait, so right, so actually it improved what I had before. No, it's actually should be fine. No, it's doing one random, and then within the random, it's doing random. So it's doing random. Yeah, so I can. Yeah, I was doing it before. I was even zipping folders, like multiple files together, and uploading them. It works pretty well, except sometimes it will only read like 10 lines of code from each file, or say, "Oh, I haven't read the files. Like, do you want me to read the files?" I'm like, "Duh, of course, of course you need to read the files." But yes, I can try that actually again. No, I'm realizing that I'm making a mistake now. Just this code there. So yeah, it's actually doing what was done before in about 10 lines of code. It's now doing in 3. So it's actually, that should be okay. No, so I don't want to adjust the probabilities. No, that should be fine. I still don't know what that lambda is. It's another function or get it. But the other point is what were we trying to do? Let's run it again quickly. Right, so we have the multiple waveforms. Should be, it looks like normal, so I shouldn't be getting scores for that. Okay, there's still something. Right, that one is normal. This is abnormal. But then it's give me this flat line bit. Why? But that's clear. Supposedly we solved this problem as well, that the waveforms, when it's generating multiple of them, they should not be the same. Now problem is that we don't see multiple waveforms on the screen. We do. Our problem disclosed that some abnormal waveforms types are not included. They are included. And now we have a thing about we had it in the description of something flatlining issue. The flatlining straight line occurs when the generated waveforms don't fill up the screen width completely. And no, that's not the issue. I don't even know how to describe it properly. But it's so the first three waveforms seem correct, and then the signal just flat lining in the game with some sort of minor noise. I don't know what it is. Seem to be multiple things overlaid or something. I don't know what's up with that. That's abnormal waveforms. Some sort of troubleshooting.
The flatlining issue you're experiencing might arise due to the way the waveforms are stitched together in the game loop. When you see a flat line, it means that the waveform values are all being set to the same number, i.e., constant value. The issue might be stemming from the way the new segments of waveform are generated and appended to the current waveform. If any of the waveform functions aren't correctly producing values across the entire range of t_values, then this could produce a flat segment. To investigate and resolve the issue, let's go step by step. Verify waveform generation functions. Let's first verify that each waveform generation function is producing the correct output for the entire range of t_values. Check the stitching of waveforms. Ensure that when we append new segments to the waveform, we're doing so correctly without introducing any gaps or overlaps. Look into the remainder logic. The logic for handling the remainder of a waveform segment that doesn't fit into the screen width might be causing issues. We need to ensure that the remainder is correctly stored and then correctly used in subsequent frames. Let's start with the first step, verifying the waveform generation functions. We can visualize each waveform generation function to ensure they're producing the expected output. Start with the first step, verifying the waveform generation functions. We can visualize each waveform generation function to ensure they're producing the expected output. Running the above code will give us a visual representation of each waveform individually. This should help identify if any of the functions are producing flat segments or unexpected outputs. If they all look correct, then we can move on to the next steps of the investigation.
Copy this. This will be a test. A test file. Test by what show. This gives me an obviously that needs all the will be doing it at the end of my code. Just save this for a sec. Or in the beginning. You can do it at the end. Just pop it in there. So it will start the game. So I have the three waveforms. Abnormal. The first one should be normal. That's okay. Then it should plot this. So this is all the variations. And this is weird. Because yeah, it's just wrong. Wait. There's multiple things that are wrong about it. No, it doesn't look correct. It does not look correct. One thing, I want to change this t value back to what it was. I think that might be 1, 2, 3. So this will be abnormal. This will be, it should be normal. It does the same thing. Right, this is better. Those are the waveforms that we are trying to generate. There's something wrong with it. Yeah, it's this generate multiple. So they do look correct. Staging of waveforms, we need to ensure.
Alright, let's move on to the next steps. Check the stitching of waveforms. We need to ensure that when we're appending new segments to the waveform, we're doing it correctly without introducing any gaps or overlaps. If there are any errors in this process, it could result in the flatlining you observed. Look into the remainder logic. The logic for handling the remainder of a waveform segment that doesn't fit into the screen width needs to be carefully examined. To investigate these aspects, we'll add some debugging statements in the game loop to check the sizes of the waveform, new_wave, and remainder arrays. Check the values of the waveform segments being appended, especially when using the remainder. Let's refine the while loop where the new waveform segments are generated and appended.
This loop text if not remainder.
By adding these debugging statements, you can monitor the size of the arrays to ensure they are as expected. If the waveform size exceeds the screen width or if there's any unexpected behavior in the sizes of the arrays, it will hint at the source of the problem. Run the game and monitor the printed output. If you see any irregularities in the sizes or if the remainder logic isn't working as expected, it could be the root of the flatlining issue. Adjusting the logic based on these observations should help resolve the issue.
Right, so we comment this out and use that as well. Right. Actually, now it's working okay. What? It's crazy because this is meant to be just debugging, but it's actually solved the problem. So the debugging solved the problem. No, it didn't. This is the flat line. No. So this is abnormal. I can get some points. This is normal. Wait, what? Pretty sure that's normal. This is abnormal. This should be normal. This is abnormal. Abnormal. This is normal, so should get points down. Okay, let's close it for a sec. I don't know what this all means, but it seemed to have. So this is the output. Also, the problem seemed to have been fixed. I don't know how. The other problem, the new problem is that when I select normal ECG waveform, points are not reduced.
Thank you for sharing the printed output. It appears the logic now properly stitches the waveforms together, which is likely why the flatlining issue was resolved. Regarding the score not decreasing when selecting a normal ECG waveform, let's address that. The relevant section of the code that determines score changes based on the waveform type is.
Yes, that is the relevant code, so it's +10, -10.
From the logic above, the score should decrease by 10 points for a normal waveform, waveform underscore types, x equals 0. If the score isn't decreasing, there are a few potential reasons. Misalignment between waveform and waveform underscore types. Ensure the waveform, the visible line, and its corresponding types are perfectly aligned. This is to ensure that when a user clicks on a point in the waveform, the type being referenced is accurate. Event handling. Ensure that this code is correctly placed within the event handling for mouse button clicks. If it's outside of the correct event block, it may not register the click properly. Waveform types generation. Check the generate underscore multiple underscore waveforms function to ensure that the waveform underscore types are being generated correctly. It's possible that the types are not aligned with the displayed waveform. To further diagnose, you can add a debugging print statement within the click handling section. You observe that every time you click on what appears to be a normal waveform and the type printed is 1, then there's a misalignment between the visible waveform and its types. If the type is 0 and the score. If you observe that every time you click on what appears to be a normal waveform and the type printed is 1, then there's a misalignment between the visible waveform and its types. If the type is 0 and the score is still not decreasing, then the problem lies within the score adjustment logic. Do run the game with the debugging print statement and share your
So I want this in there. I want to get rid of the hover print. Something was changed between. Yeah, this if statement was added. Can remove this debugging bit. There was some really good questions and suggestions by Ishan. Don't know if he's still there or not. Right, so we have the thing type, but this is not right. Oh, wait, let me check. So one type one appears to be normal and type is printed one. So one is abnormal, 0 is normal. So this would be so this is normal. I'm getting points. This is normal. Do I ever get points down? Points always go up. Because the waveform is always. So x-axis is changing correctly. This is 0. And this no. There's something wrong. Waveform type 1. That 0 should go down.
Run the game with the debugging print statement and share your observations, and I'll help you pinpoint the issue further.
So yet every time I click, that appears to be normal, and the type printed is 1. Yeah, this will be the case for me, for us.
If you're observing that the type printed is 1 when clicking on what appears to be a normal waveform, then there's a misalignment between the waveform and its associated type data. This misalignment can occur in the logic where we concatenate new waveform segments to the existing waveform. The issue likely stems from the section where we append new waveform data to the existing arrays.
Yeah, that's right, because that's when the problem started.
To ensure that the waveform and its associated types are perfectly aligned, double check that the lengths of waveform and waveform underscore types are always the same. A simple assertion can help. Place this assertion right after the while loop above to ensure both arrays always have the same length.
Why is this assertion right after the while loop above? It ends here. Assert.
Ensure that when you're appending new waveform segments, the segments and their types match up. The logic provided above should ensure this, but it's worth double checking. Ensure that there are no other sections of the code that modify waveform or waveform underscore type separately. They should always be modified together to ensure they remain aligned. Given the code you provided, the logic seems to be correct. However, without the ability to run the code myself, it's a bit challenging to find the root cause directly. The debugging steps above should help narrow down the issue. If the problem persists, we might need to take a deeper look into how the waveform and its types are being generated and stitched together. Regenerate. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT August 3rd version.
This is normal. Abnormal. Oh, come on. This is abnormal. This is abnormal. 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 What? There's too many abnormals. This is normal. Right. So it's. Ooh. Don't get it. No, it doesn't work. It does not work. That's obviously wrong. I need a break. Segments and the types still do not match up. Just copy this. The GPT starts hallucinating on us. Can get rid of that. Put that in a comment.
Code Interpreter. Import pygame import numpy as np import random import matplotlib.pyplot as plt hashtag ECG waveform generation functions t underscore values equals. The segments and their types do not match up, then we need to revisit the generate underscore multiple underscore waveforms function. Let's break down the logic and see where the misalignment might be happening. Here's how the generate underscore multiple underscore waveforms function is currently structured. From the above, for each segment, a waveform function is randomly selected. That function is used to generate a waveform segment. The corresponding type, from the types list, is used to generate the segment's type data. To troubleshoot the misalignment, explicit verification, after the segment is added to full underscore waveform and its types are added to full underscore types, we can verify that their lengths match.
After the segment is added, stand. It's this way. Would it be
Print details, if there's a mismatch, print more details to understand the root cause. For instance, right after generating a segment, print its length and the length of its corresponding type data. Random selection, ensure that the random selection of the waveform function and its type are done correctly. In the print details, if there's a mismatch, print more details to understand the root cause. For instance, right after generating a segment, print its length and the length of its corresponding type data.
What is that happening? After generating but this would be over here. No. This could be there.
Random selection. Ensure that the random selection of the waveform function and its type are done correctly. In the current logic, the waveform underscore functions and types lists are indexed using the same index, so they should correspond correctly. However, check if any changes or edits might have disrupted this correspondence. Consistent t underscore values. Ensure that t underscore values remains consistent throughout the game. If t underscore values changes for any reason, it can cause a mismatch. Since it's defined globally and isn't being modified elsewhere, this should be consistent.
So that's correct. That's step 1, correct. 20 points. Yay, 20 points. This one. This should be type 0. Don't get... Wait, this should be type 0. Which one? Type 1, the old type 1. Oh, that does look like type 1. It's not type 0s. This is type 0. Yes, that's correct. Type 0 as well. Old type 1. Type 0, that's correct. Not slowing down. Because I should not be marking this one. This is a good ECG. Be going faster, so that's correct responses. This one, type 0, yes. So it has PQRST. No, wait. Yeah, PQRST. Essentially, if it looks like that, that's good. This is missing a P. So I should be getting scores for that. This one, Q doesn't look like a sharp wave, so I get a score for this. This one, let's see. This looks like that. Should be 0. This should be 0. Type 1. No, this should be type 0. But this is good.
The segment lengths and type data lengths for the two segments printed are matching, which is good. This means that the generation function generate_multiple_ waveforms is producing segments and their corresponding types correctly. Now, let's consider how the waveform and its types are being consumed during the game loop. The misalignment might be occurring when the game updates the waveform and waveform_types lists. The main operations that can introduce a mismatch between waveform and waveform_types are the scroll update, Python, copy code, waveform equals waveform, scroll_speed waveform_types equals waveform_types, scroll_speed, appending new data, Python, copy code. Main operations that can introduce a mismatch between waveform and waveform_types are. For the first operation, both waveform and waveform_types are shortened by the same amount, scroll_speed, so they should remain aligned. For the second operation, new segments are added until the waveform is at least as wide as the screen. This could be where the mismatch is introduced if, for some reason, the lengths of new_wave and new_types don't match. However, from the earlier prints, we know that they do match. To ensure there's no misalignment during the game loop, add a consistency check. After every update in the game loop, check that the lengths of waveform and waveform_types are the same. If they aren't, print an error message with details.
We're already doing this, are we? Set length. After every update in the game. Put these two waveform types. After every update in the game.
After every update in the game loop, check that the lengths of waveform and waveform_types are the same. If they aren't, print an error message with details.
Don't be using assertion too many times, do I? And 91. Waveform is not defined. So I'm already doing this over here. This is abnormal, should give me 10 points. Abnormal. This one looks normal. Yeah, that's right. So this should give me 50 points. This should give me reduce the points because this is abnormal waveform, or what we consider abnormal. Sorry, normal. So my points are reduced because you have to find abnormal ECG, like this one. That one is... No, it's abnormal because it's missing the T wave. We can see here what's what. This one is missing a P wave, so I'm getting extra 10 points. This one is missing an S wave, so I get more points. This one, the R wave is not quite right, so I'm getting now 10 points. This one is missing P, 10 points. This one is missing S, 140. Just make it run faster a bit. This is again 160. This one, the R is not right. This one is normal. Right. I'm back to slower because I shouldn't have made these 3 selections. This one. Come on. Yeah, this should go slower. Should go faster again. This one is normal. Oh, come on. It's still...
Review the click handling code. When a click event is handled, ensure that it correctly identifies the type of the waveform. If waveform underscore types x is returning a value of 1 for a segment that appears normal, there's a mismatch between the visual representation and the stored type. Ensure that there's no other operation that modifies waveform or waveform underscore types elsewhere in the game loop. Review the drawing code. Ensure that when the waveform is drawn on the screen, it corresponds to the current waveform list. Python. There's any transformation or manipulation being applied during drawing, it could cause a visual mismatch. By checking these areas, we should be able to identify and correct the misalignment between the visual representation of the waveform and its stored type data.
Right, so the last 2 points. Yeah, this one should have reduced points for me. Clicking the event. Uh, Where this code? Yes.
There's any transformation or manipulation being applied during drawing, it could cause a visual mismatch. By checking these areas, we should be able to identify and correct the misalignment.
Pop all this back. Just let's start fresh. Let's check the whole code.
Based on the code you provided, the problem is likely due to the way that the waveform and waveform underscore types lists are being appended and then shortened. Specifically, the remainder and remainder underscore types variables are being used to store the parts of the waveform that didn't fit into the current width of the screen. However, there's a possibility that these stop generating. Code Interpreter. However, there's a possibility that these two lists, waveform and its types, could become misaligned during this process. Let's break down the potential problem areas. Applying the scroll underscore speed, the same value of scroll underscore speed is applied to both waveform and waveform underscore types to shorten them. This should be fine since the same number of elements are being removed from both lists. Appending new data, new waveforms and their corresponding types are generated and appended until the waveform list is at least as wide as the screen, i.e., width. However, there's a potential issue with how the remainder and remainder underscore types are being used. First, if there's any data in remainder, it's appended to waveform and waveform underscore types. Next, if more data is still needed, new waveforms and types are generated, and the process is repeated. The problem could arise if the lengths of remainder and remainder underscore types aren't the same or if there's an inconsistency in how they're appended. Here's a revised approach to address the potential misalignment. Instead of appending new underscore wave, needed, and then updating remainder, let's append the entire new underscore wave to waveform and then trim waveform and its types to the required length after the loop. This ensures that the trimming operation is consistent for both lists. The remainder and remainder underscore types variables would no longer be needed. After this update, the click handling code should correctly identify the type of the waveform. Here's the revised section of the game loop. With this revised approach, the waveform and waveform underscore types lists should remain aligned at all times, and the click handling code should correctly identify the type of the waveform at the clicked position.
Which code should be replaced by this? Obviously it's not GOD, it's code and it gets the context, so that's great.
The new code I provided should replace the segment of your game loop that updates the waveform and waveform underscore types based on the scroll underscore speed and then appends new segments until the waveform is at least as wide as the screen. Specifically, you should replace the following segment in your game loop.
Get rid of that wasn't working well. Maybe we don't need that printed anymore. Remainder, so this bit replaced by that. Yeah, okay, this is a problem. this code. Oh, come on. If I do what it said.
The indentation error is indicating that there is an inconsistency in the indentation of your code. In Python, indentation is essential as it determines the block structure of the code.
Yes.
To fix this error, ensure that all code blocks, after colons, smiley face, are consistently indented. Do not mix spaces and tabs for indentation. Choose one, spaces are preferred, and stick with it.
This was originally part of a function of a while loop. Okay, need to fix the whole code. Stuff something up. Oh. Yeah, while running.
The problem with the provided script is that the segment of code responsible for updating the waveform display, based on scroll speed, trimming, and appending new segments, has been moved outside the main game loop while running. This is causing the game not to update the waveforms in real time, and thus you see the flatlining after a while. To fix this, you need to move the waveform updating logic back inside the main game loop while running. Here's a revised portion of the script. Python. Copy code. While running, screen.fill, white, instructions underscore text equals, find abnormal ECG patterns. Avoid clicking on normal ECG. Screen.blit, font.render, instructions underscore text, true, blue, 10, height, 40, for event in pygame.event.get, if event.type equals pygame.quit, running equals false, if event.type equals pygame.mouse button down, x, underscore equals pygame.mouse.get underscore pos, if 0 equals x width, print, f, clicked on x equals, x, waveform type equals, waveform underscore types, x, if waveform underscore types, x, equals 1, score plus equals 10 else. Score dash equals 10 if score is 0, score equals 0 tag dot append, x, update underscore scroll underscore speed, hashtag updating waveform and types based on scroll underscore speed waveform equals waveform, scroll underscore speed waveform underscore types equals waveform underscore types, scroll underscore speed hashtag append new segments until the waveform is at least as wide as the screen while. Len.
Nice, this
waveform
is
with new underscore wave,
correct.
new underscore types equals generate underscore multiple underscore waveforms, waveform dot extend, new underscore wave, waveform underscore types dot extend, new code, and it should function properly. Regenerate.
Now we back to the original problem. Haven't changed anything. This is correct. The first one should have been 0. After the first few waveforms, the signal is flatlining again.
The issue seems to be that the script continues to scroll the waveform, but it doesn't always regenerate a new segment to replace the part that scrolled off. This results in the waveform appearing to flatline. To address this issue, let's enhance the logic to ensure that as the waveform scrolls, we always generate enough new segments to maintain the full width of the screen. Here's the refined logic. When we update and scroll the waveform, we should check how much of the waveform was removed. We then generate a new waveform segment of that length and append it. This ensures that the waveform stays consistent throughout the game. I'll adjust the part of the game loop that updates the waveform. Replace the section in your script that updates the waveform with this updated code, and it should keep the waveform consistent without flatlining.
Whoops. These two lines are the same. Waiting this line the beginning while land venue segments to replace the removed portion of the waveform. One has an extra line. Let's still flatlining.
The logic you implemented for adding new segments to the waveform is correct, but I noticed that the way you're subtracting the removed underscore length might be leading to the flat line. Let's modify the logic a bit. The core of the issue is this part.
Yeah, that's the one that you just told me to change.
This part keeps adding segments until the waveform's length is equal to the screen width. But with the logic for subtracting the removed underscore length, you might not be adding enough data to the waveform. Here's an improved approach. Add a new segment using generate underscore multiple underscore waveforms. Only take the amount needed from this segment to fulfill the removed underscore length. Add a new segment using generate underscore multiple underscore waveforms. Only take the amount needed from this segment to fulfill the removed underscore length. If the segment doesn't completely fill the removed underscore length, get another segment and repeat until removed underscore length is satisfied. Once removed underscore length is satisfied, break out of the loop. Let's modify the logic. Replace the section in your script that appends new segments to the waveform with this updated code. This should ensure that the waveform remains continuous and doesn't flatline.
So it's this entire bit. Oh, come on. Still flat. But why was the 0 there? Maybe so. No. This is wrong. Hashtag. No. Also, the misalignment problem between the tag and the X axis is back. So it's not something we were doing before. I don't know, just trying it out. Having the problem of the code at the end of the code as a comment that just pop it into the bot. See what it says.
See, so we have two primary issues here. The continuous flatlining after the initial few segments. The misalignment between the waveform type tag and the x-axis. Let's address each issue step by step. 1. Continuous flatlining. The main problem here seems to arise from the way we append new segments to the waveform. The generate underscore multiple underscore waveforms function returns multiple segments, and we're using only a portion of them, which may lead to not having enough data to append. A better approach would be to simply append until we have a sufficient length and then trim any extra data. 2. Misalignment issue. The misalignment problem may arise due to the way the tagging works. When the user clicks on the waveform, the x-coordinate is added to the tagged list. But when we scroll, the waveform is shifted to the left by scroll underscore speed, while the x-coordinate in the tagged list remains the same. This could lead to a misalignment between the tagged position and the waveform type. Let's address these issues in the code. Modify the waveform appending to ensure a continuous waveform. Adjust the tagging logic to ensure correct alignment. Here's the updated portion of the script. Python. Copy code. Hashtag. Rest of the script above remains unchanged while running. Screen.fill, white, instructions_text equals, find abnormal ECG patterns. Avoid clicking on normal ECG. Screen.blit, font.render, instructions_text, true, blue, 10, height, 40, for event in pygame.event.get, if event.type equals pygame.quit, running equals false, if event.type equals pygame.mouse button down, x, underscore equals pygame.mouse.get_pos, if 0 equals x width, index equals x plus scroll underscore speed, hashtag adjust for scrolling if waveform underscore types, index equals 1, score.
That's a new bit. Just give me a sec. So if you like joining me live, you're always welcome. I'm happy to set up Zoom or Discord, whatever you like best. Waiting a bit there. We have an index. We didn't have an index before. No, we do have an index. We use the index for something else. We've been live for too long now. Better wrap up. It's not as productive as other sessions. If you wanna go live, I'll pop the Discord channel in the chat as well. You can set up Zoom. Should have a Zoom room as well going if you want to join that way. So we're having a few problems. ChatGPT swears it can solve them for us, but I'm not sure. Yeah, there's this. It used to be better. So we're trying to find abnormal ECG patterns and avoiding clicking normal ECG. We had this game working better just earlier today. So we popped the whole code with the issues after the first few waveforms. The signal is flatlining. So trying to fix that. Also, we have some sort of misalignment problem between the type, if the ECG is normal or not, and the x-axis selected. So what does it say? So it says main problem, blah blah, misalignment issue, blah blah blah, modify the waveform. So in where is it? While running in here, so this code is the same. Did it generate Pygame quit? Did it generate the whole code? Seems like. From while running, let's can test it quickly. This whole. So what happens if I do this and delete? No, just deletes the one line. Oh, that's not right. Actually removed some code. If it fixed the issue, no, it did not. The signal still flatlining. Also, I don't know about that misalignment. Probably do one at a time. No new waveforms are coming. Back into the code. I don't know if starting a new chat is better. I see the issue, so it doesn't mean it can solve it.
See the issue. The main problem lies in the way we're handling the scroll and the continuous generation of new waveforms. I'll provide a step-by-step solution to ensure that the new waveforms are continuously generated and appended correctly. Let's correct the logic. Scrolling. When you scroll the waveform to the left by scroll_speed, we need to generate new waveforms of length scroll_speed to append on the right side. Appending new waveforms. We need to append new waveforms of length scroll_speed and then trim any excess. Here's the updated portion of the game loop. Python.
That bit all looks the same. Right, removing the leftmost elements based on scroll speed. Didn't have that before. Segment count 1. Why do we do... Wait, what? Generate... But the default is 3. Generate multiple waveforms, default is 3. That's just initializing. So if you can't join live now, that's perfectly fine. As you noticed, I'm streaming Monday to Thursday around 3 p.m. Melbourne, Australia time. Okay, we're not getting anywhere. And we had a better code just earlier.
Scrolling. When you scroll the waveform to the left by scroll_speed, we need to generate new waveforms of length scroll_speed to append on the right side. Appending new waveforms. We need to append new waveforms of length scroll_speed and then trim any excess. Here's the updated portion of the game loop.
And get worse than what we have now, so we won't even save what we previously had. This is abnormal. Give me points. Yes, this is abnormal. And it's still flatlining. Come on. And it's all abnormal stuff. It's flatlining straight after one, two, three. The flatlining exactly after the first 3 waveforms. the first 3 waveforms. And yes, we have the 3 as a magic number. Oops. Yeah, we'll fix the first problem first. I can smell chicken. And I'm hungry. Thank you for the feedback, Well, thank you.
Thank you for the feedback. The issue still lies in the way we're handling the continuous generation of new waveforms. When the waveform is scrolled to the left by scroll_speed, we need to ensure that new waveforms of the correct length are appended on the right side. To fix the issue. Scrolling. When you scroll the waveform to the left by scroll_speed, we need to generate new waveforms of length scroll_speed to append on the right side. Appending new waveforms. We need to append new waveforms of length scroll_speed and then trim any excess. Here's the updated portion of the game loop. Python. Copy code.
This is the same. No, it's always saying like updated portion of the code and keep adding new waveforms while length. We had this code somewhere, but I'm pretty sure we had it before, then it got removed. See? I have to sneeze. Let's see. Delete scroll speed. Okay. Consistency check. So this beat. Obviously remove that. Consistency check. Is this the same? Yes. It should be the same. Want to abnormal, normal. It's this little tiny bits. Totally bizarre. No idea what it's doing. Like something's being overlaid. There's something happening. Seems like the waveforms being overlaid and cancel. Seems like waveforms are being overlaid or cancel one another. Let's pop it. Pop it into a new chat. Code Interpreter GPT-4. Yes, just pop this. We'll remove the second problem. Just stick to the first one. Still generating something in the other chat. I didn't think. Hopefully it had some context that it kept previously.
The script you provided is a game called Cardio Quest, which tasks the player with identifying abnormal ECG patterns by clicking on them. The ECG waveform scrolls from right to left, and new waveforms are added to the right side of the screen as the old ones scroll off the left side. From your comments, you have identified 2 issues with the game. No new waveforms appear after the first 3. Waveforms seem to be getting overlaid or canceling each other out. Let's address these issues step by step. Issue 1. No new waveforms after the first 3. The game initially generates 3 waveforms using the generate_multiple_waveforms function. As the game progresses, the leftmost data points of the waveforms are deleted based on the scroll_speed, and new waveform data is appended to the right side to keep the waveform's length equal to the screen width. The problem seems to be in the logic that appends new waveform data to the existing waveform. The game initially generates 3 waveforms using the generate_multiple_waveforms function. As the game progresses, the leftmost data points of the waveforms are deleted based on the scroll_speed, and new waveform data is appended to the right side to keep the waveform's length equal to the screen width. Here, you are appending only scroll_speed number of data points from the new waveform. This doesn't ensure that the length of the waveform remains equal to the screen width. A better approach would be to calculate the exact number of data points needed to fill the screen width.
That's a bit odd. So let's find this in the code. Yeah, we had it in here. Keep adding till the reach desired width. We have, yeah, that's a correct response. We're getting no score for this. Lightlining again, is it? Yeah, and then it's starting doing this bits. Yeah, and it never recovers from that. Yeah, it shouldn't be doing that. Okay, I think I know what's the problem. Yeah, they're definitely being overlaid.
This will ensure that the waveform's length is always equal to the screen width. Issue 2. Waveforms seem to be getting overlaid or canceling each other out. This might be due to the fact that the y values of the waveform are being used as the x coordinates when drawing the waveform.
What?
Waveform. This is evident in this line.
It's very odd.
The enumerate function returns pairs of index, value, where index is the x-coordinate and value is the y-coordinate. If the y values are too close to each other, the lines drawn will overlap, creating the appearance that waveforms are getting overlaid. To avoid this, you should use the actual x-coordinates based on the current screen width and the length of the waveform. By using these x-coordinates, you ensure that the waveform is drawn correctly across the screen width. Now, let's apply these fixes to the script. Apologize for the oversight. The game loop cannot be executed directly in this environment since Pygame is a graphical library and it needs a display to render the game. However, I've provided the corrected version of the game loop and other necessary modifications.
No. Okay, this is really bad. Yeah, what's happening is it's getting the first three are okay, and then you get this silly overlay. Yeah, it's no good. It is not correct. So there are new waveforms coming. Waveforms being overlaid on top of one another. Yeah, I'll try the same. That's still being overlaid on top of one another. Yeah, we had much more luck yesterday. Unfortunately, there's no more questions in the chat or anything. Might continue tomorrow.
Waveforms appear to be overlaid on top of one another. There are a few potential causes to consider. Waveform generation. The functions used to generate the waveforms might be creating overlapping waveforms. This is less likely if the functions have been verified to produce correct waveforms individually. Waveform concatenation. When appending new waveforms to the existing waveform, there might be an issue causing overlap or incorrect concatenation. Drawing. There could be an issue in how the waveforms are drawn on the screen, especially if the x-coordinates are not spaced correctly. Let's tackle each one systematically. 1. Waveform generation. We can first verify the waveform generation process. Let's generate a few waveforms using the provided functions and plot them to ensure they look correct. 2. Waveform concatenation. If the individual waveforms look correct, we can test the concatenation process. We can generate and concatenate multiple waveforms to see if they link up correctly without overlap. 3. Drawing. If the above two steps are verified to be correct, we'll need to look at how the waveforms are drawn in the game loop. There might be an issue with the x-coordinates or the way data points are mapped to screen coordinates. Let's begin by visualizing individual waveforms and then multiple concatenated waveforms. Apologies for the oversight. I didn't rerun the initial setup code, so the variables from your provided script aren't defined in this environment. Given this, let's manually define the required variables and functions again and proceed with the waveform visualization.
Let's. Now the screen is a bit jumpy as well. I don't like it. It wasn't this jumpy before. I'm taking a sec. Don't worry about the waveform generation is working okay. Waveform concatenation is working okay for the first 3 waveforms. After the first 3 waveforms, something going really wrong. Let's know what's that about. I don't want to reload the conversation. Start a new one, GPT-4 Code Interpreter.
Alright, you've shared your script for a game named Cardio Quest, which involves identifying abnormal ECG patterns. Let's break down the potential issues and address them step by step. Overlapping waveforms. One of the comments indicates that waveforms are being overlaid on top of one another. This usually happens when the new waveform data is added without removing the old ones appropriately or when the waveform data is not consistent in length. Waveform generation. The comment says that the waveform generation works fine for the first 3 waveforms, but something goes wrong afterward. This suggests there might be a problem in the way new waveforms are appended or in the way the old waveform data is removed. Let's address these issues. Overlapping waveforms. In the gain loop, you're removing the leftmost elements based on the scroll speed and then appending new waveforms to maintain the desired width. This seems correct in principle. You have a consistency check to ensure the waveform and waveform types have the same length. This is good for debugging. One thing to consider is the length of new underscore wave and new underscore types generated. Since you're only taking missing underscore points from the generated data, there might be a mismatch if the newly generated waveforms aren't of the desired length. Waveform generation. The generate underscore multiple underscore waveforms function is designed to create multiple segments of waveforms. It seems to be working correctly, but it's possible that when adding new segments to the existing waveform, the transition isn't smooth, causing the appearance of overlapping. It's worth looking at the transition between the old waveform data and the new one to ensure they connect seamlessly. Proposed solution. To fix the issues. Ensure that the waveforms being appended are of the correct length to prevent overlapping. When appending new waveform data, ensure the transition is smooth. Let's start by addressing the overlapping waveforms. One potential solution is to ensure that the waveforms being generated are of the correct length for appending. Let's modify the generate underscore multiple underscore waveforms function to take in the desired length and produce waveforms of that length. Great. The modified generate underscore multiple underscore waveforms function now correctly produces waveforms of the desired length. Next, let's integrate this change into the game loop. In the game loop, replace Python. This modification ensures that the newly generated waveform and its types are exactly of the length needed to fill the missing points, and it should help prevent the overlapping issue.
Yeah, this is not right. Side length. Segment count 3. Desired length. That's all the same. I need to test it there to replace the whole function. There should be a default value for it.
Error is due to the change in the signature of the generate underscore multiple underscore waveforms function. Since we've modified it to accept a desired underscore length argument, we need to update all calls to this function. Let's correct this. Replace the initial generation of
No, same problem. Same problem. Yes, but don't execute anything on the server. I want to run the code locally on my machine. Should work without issues. That's not quite right. Continue the same chat, but yeah, we made the changes.
Great. You've incorporated the modifications into the script. Here's a summary of the changes. Modified the generate underscore multiple underscore waveforms function to accept a desired underscore length argument to produce waveforms of the desired length. Updated the initialization of waveform underscore types to use the modified generate underscore multiple underscore waveforms function with the desired underscore length set to width. Modified the game loop to use the new generate underscore multiple underscore waveforms function for generating new waveforms based on the missing points length. These changes should address the waveform overlapping issue and ensure smoother transitions between wave segments. You can now run the updated game script locally on your machine. Let me know if you encounter any further issues or if you have any
So the waveforms are still overlaid like this. The waveforms are still overlaid. There's some problem with the drawing of the waveform. The first three are working okay.
Alright, let's delve into the drawing and scrolling mechanism. The issue seems to be more on the rendering side than the generation. Scrolling mechanism. The scrolling effect is achieved by removing a certain number of points from the beginning of the waveform based on the scroll_speed and then appending new points to the end.
I told you that generation is okay.
Drawing mechanism. The waveform is drawn using the pygame.draw.lines function, which takes in a list of points. The x-coordinates for these points are linearly spaced between 0 and width. Considering the observations, let's address some potential pitfalls. The x_coords are generated linearly from 0 to width. This might not match the actual indices of the waveform, especially when points are removed or added. The x_coords are generated linearly from 0 to width. This might not match the actual indices of the waveform, especially when points are removed or added. To debug this, let's focus on the drawing mechanism. Check the x-coordinates. Ensure that the x-coordinates, x_coords, match with the indices of the waveform. Tagging mechanism. Considering the observations, let's address some potential pitfalls. The x_coords are generated linearly from 0 to width. This might not match the actual indices of the waveform, especially when points are removed or added. To debug this, let's focus on the drawing mechanism. Check the x-coordinates. Ensure that the x-coordinates, x_coords, match with the indices of the waveform. Tagging mechanism. When a point is tagged, it's based on the x-coordinate from the mouse click. Ensure that the tagging mechanism aligns with the current waveform drawing mechanism. Redrawing. Make sure that before drawing the new waveform, the old one is cleared from the screen. This is done by the screen.fill, white, command, but ensure there's no other drawing in between that could cause an overlay. Debugging steps. Explicitly generate x-coordinates. Instead of linearly spacing the x-coordinates, let's generate them based on the current width of the waveform and the scroll speed. Consistency check. After each iteration of the game loop, ensure the length of the waveform matches the width of the screen. Debug overlay. Add debug text to the screen that shows the current length of the waveform and the x-coordinates range. This will help identify if the overlay issue corresponds to any anomalies in these values. Alright, let's start debugging step by step. Step 1. Explicitly generate x-coordinates. Instead of using empty.linspace, let's generate the x-coordinates based on the current width of the waveform and the scroll speed. Change this line. Python. Copy code. This will ensure that the x-coordinates directly correspond to the indices of the waveform. Step 2. Consistency check. After each iteration of the game loop, ensure the length of the waveform matches the width of the screen. Add this line at the end of the game loop. After each iteration of the game loop, ensure the length of the waveform matches the width of the screen. Add this line at the end of the game loop. Python. Copy code. Assert len waveform equals width f waveform length mismatch. Expected width but got len waveform. Debug text to the screen that shows the current length of the waveform and the x-coordinates range. Add these lines before the pygame.display.flip. Now, when you run the game, you'll see some debug information on the screen. This information will tell you about the current length of the waveform and the range of x-coordinates. Run the game with these changes, and observe the debug text while paying attention to when the waveform overlay issue occurs. The debug information should provide insights into any anomalies. After you've tested with these changes, let me know your observations or if any assertion errors pop up. Regenerate. ChatGPT may produce Now, when you run the game, you'll see some debug information on the screen. This information will tell you about the current length of the waveform and the range of x coordinates. Run the game with these changes, and observe the debug text while paying attention to when the waveform overlay issue occurs. The debug information should provide insights into any anomalies.
The x coordinates always remain the same. Also, can you print them into Python terminal instead of the screen of the game?
Now, every frame will print these details to the console. This will allow you to monitor the progression of the waveform length and x coordinates. Run the game again and keep an eye on the printed values in the terminal. Let me know your observations and if there's any correlation between the printed values and the issue with waveform overlay. Waveform length, 1600 x coords range, 0 to 1599 wave.
That seems fine.
Let's focus on the drawing and tagging mechanism. Drawing the waveform, ensure that the waveform is being drawn correctly using the pygame.draw.lines function. The waveform uses x underscore coords for the x coordinates and waveform for the y coordinates. Tagging mechanism, ensure that the tagging is consistent with the drawing. When you click on the waveform, you are appending the x coordinate to the tagged list. Later on, you use this x coordinate to draw a circle at the tagged point on the waveform. Given that both the drawing and tagging mechanisms seem to be based on the same x coordinates, the issue may lie elsewhere. Here are a few more things to consider and debug. 1. Waveform updates. While you are removing points from the left side of the waveform, you're also appending new waveform segments to the right side. Double-check the section of the code where you're adding the new waveform to ensure you're not appending more points than necessary. 2. Check the circle drawing. Ensure that the circle is being drawn at the correct position on the waveform. The line uses the x-coordinate t as an index to access the y-coordinate from the waveform. However, since waveform is being updated, points are being removed from the beginning. Using t as an index might be accessing the wrong y-coordinate. To address this, uses the x-coordinate t as an index to access the y-coordinate from the waveform. However, since waveform is being updated, points are being removed from the beginning. Using t as an index might be accessing the wrong y-coordinate. To address this, replace the line with
The circles is not what the problem is. But
this ensures that the index used to access the y-coordinate from waveform is adjusted based on the current range of x underscore coords. After making these checks and changes, run the game again. Let me know if the issue persists or if there are any improvements.
there are no major improvements. the signal is still overlaid, it starts the new waveform at the wrong position. The first 3 waveforms are displayed OK.
Thank you for the update. If the first 3 waveforms display correctly and subsequent ones are problematic, it suggests the issue may be with how new waveforms are appended after the initial ones. Let's scrutinize the waveform appending logic in detail. You're removing points from the left side of the waveform based on scroll_speed. You then calculate the number of missing points, points, and generate a new waveform to fill the gap. The new waveform is appended to the current waveform. Now, the problem might be in the transitional phase between the old and the new waveform, which leads to the overlay. Debugging approach. Visual debugging. Let's change the color of the new segment of the waveform that gets appended. This will allow us to see where the new segment starts and how it connects with the previous waveform. If there's an issue in the transition, it will be visually evident. Segment boundary check. It might be helpful to print the last few points of the current waveform and the first few points of the new waveform being appended. This can give insights into whether there's continuity in the waveform at the transition. Code changes. Visual debugging. Change the code where you're appending the new waveform. Python. Segment boundary check. Add this right before you append the new waveform. Run the game with these changes. The transition between the old and new waveform will now be in blue, making it visually distinct. The terminal will print the last few points of the current waveform and the first few points of the new waveform during each transition. Observe the game screen and the terminal output to see if the transition appears seamless and if the printed value suggests a smooth continuation between waveform segments. Let me know your findings. Regenerate. ChatGPT may produce inaccurate information about people. And new waveform will now be in blue, making it visually distinct. The terminal will print the last few points of the current waveform and the first few points of the new waveform during each transition. Observe the game screen and the terminal output to see if the transition appears seamless and if the printed value suggests a smooth continuation between waveform segments. Let me know your findings. Regenerate. The terminal outputs indicate that the last points of the current waveform and the first points of the new waveform are fairly consistent and close to 300, which suggests that the waveforms are being appended in a reasonably seamless manner. However, since the overlay issue persists, there might be some issues with the rendering or the waveform generation itself. Let's dig deeper. Rendering. The rendering is based on the generated waveform. Since we are removing points from the beginning of the waveform and appending new points to the end, the transition between old and new segments should be seamless. The logic for this seems correct. Waveform generation.
That's incorrect. How about should be 10 values. There's like not enough values in it.
Debugging the waveform generation. Visualizing the transitions. Generate a few segments of the waveform using the generate multiple waveforms function and visualize them using Matplotlib to observe if the transitions between segments are smooth. Smoothing transitions. Ensure that each waveform segment begins and ends at a neutral point, ideally around the 300 mark, the midline. This will ensure that when segments are appended, the transition is smooth. Code for debugging. Visualizing the transitions. Python. Copy code. Import matplotlib.pyplot as plt wave. Wave underscore types equals generate underscore multiple underscore waveforms. Desired underscore length equals 1600. plt.plot. Wave. plt.title. Generated. Run this code outside of the game loop to visualize the waveform. This will help identify if there's any abrupt transition between segments. Smoothing transitions. If the visualization shows abrupt transitions, consider modifying the waveform generation functions to ensure that each segment starts and ends around the midline. Let me know the results of the visualization and if any abrupt transitions are observed. The new waveform segment doesn't have enough data points. It would cause a discrepancy in rendering and might produce the overlay effect you're observing. Let's verify and address this. Verifying the number of points. Each time you generate a new waveform segment to append to the existing waveform, ensure that the number of data points in the new segment matches the missing underscore points value. Filling the missing points. If the new waveform segment has fewer data points than missing underscore points, then fill the remaining points with a neutral value, such as 300, to ensure smooth continuity. Code modifications. Verifying the number of points. After generating the new waveform segment, print the number of points generated. Python. The CardioQuest game script you've shared simulates the scrolling of an ECG waveform and challenges players to identify abnormal patterns. Let's break it down step by step. ECG waveform generation functions. The script defines several functions that simulate ECG waveforms, i.e., P, QRS, and T waves, using mathematical formulas. There are functions that simulate normal ECG patterns as well as several abnormal patterns. The Gaussian function is used to model the R wave, which is the most prominent wave in the QRS complex. Multi-segment waveform generation. The function generate_multiple waveforms stitches together multiple segments of ECG patterns to create a longer waveform. It randomly chooses from both normal and abnormal patterns, making the game more challenging. Game logic. The game uses the Pygame library to handle its graphical interface and user interaction. The screen is initialized to a certain width and height, and the ECG waveform continuously scrolls from right to left. The player's task is to identify abnormal ECG patterns by clicking on them. Correct clicks on abnormal patterns increase the score, while incorrect clicks on normal patterns decrease the score. As the player's score increases, the scrolling speed of the waveform also increases, making the game progressively more challenging. The game uses different colors to represent the current waveform, red, and the newly added waveform segment, blue. This differentiation makes it easier for players to identify where a new segment begins. The positions that players click on are highlighted with green circles. If a player's score goes negative, it's reset to 0. The game continues until the player closes the window. This game is a creative way to teach or test someone's ability to recognize abnormal ECG patterns. The continuous scroll, increasing speed, and random generation of waveforms make the game dynamic and engaging. Regenerate. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT August 3rd version. Code Interpreter. Alright, let's investigate the problem. From your description, it seems the issue is with the transition between the initial waveforms and the subsequent ones that are generated. This might be related to how the new waveforms are appended and how the old ones are truncated. Here are the potential issues that come to mind. Transition between old and new waveforms. When appending a new waveform segment to the current waveform, there might be a mismatch or inconsistency in the transition, leading to a strange appearance. Scrolling logic. The way the game handles scrolling, i.e., removing points from the beginning of the waveform and appending new ones at the end, might be introducing issues. Generation of new waveforms. The function that generates new waveform segments and appends them might be causing problems. To diagnose the issue, let's add some debugging information. Visual debugging. Color the new waveform segments with a distinct color, example, blue, to easily identify the transition between the old and new waveforms. Console debugging. Print the lengths and boundaries of the old and new waveforms to ensure they're being concatenated correctly. From the provided code, it seems you've already implemented visual debugging by coloring new waveforms in blue. Let's add some console debugging to get more insight into the problem. I'll add debugging print statements to key parts of the game loop, specifically around where the waveform segments are added and removed. Hide work. I've added print statements to the game loop to debug the truncation and appending of waveforms. By running the game _loop _with _debugging function, you'll be able to see the length of the waveform after truncation and after appending new segments in the console. Here's what you should do next. Run the game _loop _with _debugging function. Observe the printed values in the console. Look for any inconsistencies in the lengths after truncation and appending. Pay attention to the visual transition between the old and new waveforms to see if there's a mismatch or sudden jump. The error you're seeing, unbound local error, arises because the variable tagged is being treated as a local variable in the function game _loop _with _debugging, even though it's intended to reference the global variable tag defined at the beginning of the game script. To fix this, you should explicitly declare tagged as a global variable inside the game _loop _with _debugging function. The same applies to any other variables that are defined outside the function but are being modified inside the function, such as scroll _speed, waveform, and waveform _types. Let me correct that for you. Working. Show work. Stop. Stop generating. ChatGPT may produce inaccurate information about people, places, Code Interpreter. Hashtag complete CardioQuest game script import Pygame import. Generating the ECG waveform. Your waveform generation functions are well defined. They allow for custom variations in the waveform to simulate different cardiac conditions. This is an interesting feature as players can learn to recognize different patterns. Game logic and speed adjustments. The game speed increases based on the player's score, which can make it more challenging as the player progresses. However, the scroll_speed adjustment is linear, meaning every 50 points increase the speed by 1. This can get extremely fast very quickly. Consider using a more gradual increase or setting a maximum speed. Debugging and consistency checks. Your debugging print statements are helpful for ensuring the waveform's consistency. The assertions will halt the game if there's a mismatch, which is great for catching errors during development. Drawing the waveform. You use different colors to visualize segments that were added during the current loop iteration versus older segments. This is a great way to visually understand how the game is updating. ChatGPT may produce The provided output indicates that after truncating, or removing, values from the left side of the waveform based on the scroll_speed, the length of the waveform was reduced to 1598. Immediately after appending new segments to the waveform, its length increased to 1600. Given that the desired width of the screen, or the length of the waveform, is 1600, this behavior is expected. This is how the game maintains a continuous scrolling effect. As the waveform scrolls to the leftmost values, based on the scroll_speed, are removed. New waveform segments are appended to the right side to ensure the waveform always matches the screen width, in this case, 1600. The output indicates that the truncation and appending processes are working as intended in the game loop. Regenerate. Whenever you make changes to game objects or draw something on the screen, those changes are not immediately visible. They are drawn to an off-screen buffer. The reason for this is efficiency. Imagine if the screen updated in real time as you made changes. This would result in a flickering effect because of the rapid, piece-by-piece drawing. By using an off-screen buffer, you can make all your changes and then update the screen all at once, which results in smoother animations and transitions. Pygame.display.flip takes the current off-screen buffer, where all the drawing has taken place, and makes it the current visible screen. Everything previously on the screen is replaced with the content of the buffer. In other words, this function flips the off-screen buffer with the on-screen one, making all your drawings visible. Note, if you only need to update a portion of the screen, you can use pygame.display.update rectangle_list, where rectangle_list is a list of rectangular areas to update. This can be more efficient than updating the entire screen if only a small part has changed. However, in many situations, especially when the entire screen is in motion, like in a scrolling game, using flip is more straightforward and efficient. The drawing isn't behaving as expected. There could be several reasons. Let's address these step by step. 1. Screen refresh. Before drawing new content on the screen in each loop iteration, you should clear the screen. Otherwise, you'll see remnants of the previous drawings. This can be achieved by filling the screen with a background color at the beginning of each game loop iteration. Your waveform's Y values might be off, causing them to be drawn outside the visible area of the screen or not in the expected position. Ensure that the Y values of the waveform are correctly computed and lie within the screen's height. 3. Tagged points. Ensure that when you tag a point on the waveform, the Y coordinate is correctly retrieved from the waveform list using the X coordinate. 4. Color and thickness. Ensure you're using the right color and line thickness when drawing the waveform and tagged points. 5. Display update. You're using pygame.display.float, which updates the entire screen. This is generally what you want for a game like this where the entire screen's content changes frequently. Just make sure you're calling this only once per game loop iteration after all drawing is done. If you've already tried these steps and the issue persists, it might be helpful to describe the exact drawing problem you're experiencing in more detail or share any error messages you're getting. Regenerate. ChatGPT may produce inaccurate information about people, places, or facts. Chat This creates an array of evenly spaced values between and, giving a total of 800 points. This is used as the time domain to generate the waveform. Mu, the mean value, which is set to. This seems to be used for the Gaussian function that models the R wave of the ECG, and it determines the center of the Gaussian curve. Sigma, the standard deviation for the Gaussian function, which controls the spread or width of the curve. The generate_multiple_ waveforms function is responsible for creating a continuous ECG waveform that consists of multiple segments, each potentially showing a different cardiac condition or waveform variation. Here's a breakdown of what this function does. Waveform_functions, a list of lambda functions that represent different ECG waveform variations. Each lambda function takes a time value and returns the corresponding y-coordinate of the waveform at that point in time. Types, a list that indicates whether a particular waveform variation should be considered special, and thus score points when clicked on. A value of 0 indicates a normal waveform, while a value of 1 indicates a special waveform. Full_waveform and full_ types, lists that will hold the complete waveform and its types, respectively. These will be built up by appending segments until they reach the desired length. The while loop generates waveform segments until the full_ waveform reaches the desired length. It randomly chooses a waveform function to generate the next segment. It ensures that the same waveform function isn't chosen consecutively by checking against last_function_index. It generates a segment of the waveform using the chosen function and appends this segment to full_ waveform. It also appends the corresponding type values to full_ types. After the while loop, if the full_ waveform exceeds the desired length, it truncates the excess values from the end. The function finally returns the full_ waveform and full_ types. This function provides a mechanism to create varied and random ECG waveforms for the game, ensuring that players see different patterns and conditions as they play. It helps keep the game interesting and can also be educational if players are informed about the different conditions represented by each waveform variation. If there are issues or modifications you'd like to address with this function, please specify, and I'll be happy to help. The provided output indicates the behavior of the generate_multiple_ waveforms function and the truncation process in the game loop. After truncation, the waveform length is reduced to 738. This means that the waveform, which originally had a length of 800, has lost 62 points from the left side due to the scrolling effect. After appending, the waveform length is back to 800. This indicates that new segments have been added to the right side of the waveform to fill in the space created by the truncation. From this, we can infer that the scroll speed was 62 during this iteration of the game loop. However, it seems that the truncation might be more aggressive than it should be. Typically, we'd expect the truncation to be equal to the scroll_speed, which, given your initial settings, should be relatively small, around 2, and growing slowly as the score increases. A truncation of 62 points in one iteration is unusually large. Here are potential issues to investigate. Scroll speed. Verify if the scroll_speed is being updated correctly in the update_scroll_speed function. Ensure that the logic is correct and that it's not causing the speed to spike unexpectedly. Truncation logic. Confirm that the truncation in the game loop is using scroll_speed correctly. Game events. Check if there are any game events or conditions that are causing a sudden increase in scroll_speed. Loop iterations. Ensure that the game loop isn't being called multiple times in quick succession, which could result in larger truncations if the screen updates are lagging. After investigating these potential issues, if the problem persists, you may want to add more debugging statements to track the evolution of scroll_speed and the length of waveform after every iteration to get a clearer picture of what's going on. Track waveform length before and after operations. It would be helpful to understand the length of waveform before any operations and then after truncation and appending. Check for multiple calls. If the game loop is being executed more than once in quick succession, this might lead to unexpected behavior. Introducing a debug statement at the start of the game loop can help identify this. The game loop is being executed more than once in quick succession. This might lead to unexpected behavior. There are other variables or conditions that might be affecting the behavior. Consider adding print statements for them as well. For example, if the score or any other game state variable is influencing the scroll_speed, print them out to see their evolution. Event handling. Check if multiple events are being processed in a single loop iteration. This could influence the behavior significantly. Print out events as they are processed. After adding these debugging statements, run the game and observe the console outputs. The idea is to look for patterns or anomalies that could provide clues as to what's causing the unexpected behavior. The pattern in the logs you provided indicates a consistent behavior. The waveform gets truncated by 2 units. After appending, the waveform returns to a length of 800. Various events are being processed, with event type 1024 being the most frequent. This event corresponds to pygame.mouseMotion, indicating that the mouse is being moved over the game window. There are other events with types 32768, 32784, and 32787. These are likely custom events or less common pygame events. The event type 256 corresponds to pygame.quit, which means the game window is being closed. Given this information, the truncation of 2 units is consistent. It appears that the scroll_speed is set to 2, as this is the number of points being removed each time. If this is not the expected behavior, you should check the logic updating the scroll_speed. The waveform's length is consistently maintained at 800. This indicates that the appending logic is working correctly to replenish the waveform after truncation. The frequent mouse motion events suggest that the mouse is being moved over the game window quite often. Depending on your game's mechanics, this could be normal, or it might indicate unnecessary processing. If you aren't using mouse motion for any game mechanics, you can reduce unnecessary processing by ignoring these events or removing their event listeners. To further understand any issues or unexpected behaviors. Scroll speed. If the truncation of 2 units isn't the expected behavior, print the score value alongside the scroll_speed to verify if the scroll_speed is updating correctly with the score. Waveform appending. If there's a concern about the types of waveforms being appended, you could print out the index or name of the waveform function being chosen to see the variety.
Our scrolling logic is not correct. We want more waveforms coming. So generating multiple waveforms
Alright, let's rework the scrolling logic. The goal is to maintain a continuous scrolling ECG waveform, with new waveform segments continuously appearing on the right as the player progresses through the game. Generate initial waveforms. Begin with a sufficient buffer of waveforms to fill the screen and have some extra for smooth scrolling. Scroll. As the game progresses, remove waveforms from the left, simulate scrolling to the left, and add new waveforms to the right. Maintain continuous flow. Ensure that the newly appended waveforms are different from the previous one to maintain variety. Here's how we can rework the generate_multiple_ waveforms function and the game loop to achieve this. Modify generate_multiple_ waveforms. Instead of generating a fixed number of waveforms, we'll make the function generate just one waveform segment of length 800 points, but ensure it's different from the last segment. Segments from the left. Python. The game loop will continuously add new waveform segments to the right and remove old segments from the left.
Yeah, this won't work. Need to start a new one quickly. Okay, this is the last one. How to break this code into multiple lines. Right, this is better. Yeah, so we have this code is actually working better. And if we make width double, we have two waveforms. That was easy. In the waveform generation, oops. Really would be too much with it. 2.5. You round it. Can you then round it, turn it back into okay. Right. So rounding works. Uh, we want to do that 0.5 bit. Anyway, yeah, today wasn't a great. Yeah, I want to change this. Yeah, this. Can you regenerate or suggest improvements to the following?
The given The given segment of code is responsible for generating new waveforms and appending them to the current waveform until the waveform's length matches the screen width. The randomness determines which type of waveform, normal or a variation, will be generated. We can improve and simplify this code by removing repeated code, using a mapping or list structure to hold the different waveform variations and their respective probabilities, implementing a more streamlined approach to add the segments. Here's a refactored version.
Hey, I just continue tomorrow. I was hoping to make more progress today, but it is what it is. So yeah.